Chemistry practicals. So how to use the initial rates method. Repeat an experiment several times using different initial concentrations of reactions. Usually only change one of the concentrations at a time, keeping the rest constant. However, there are exam questions where they change more than one of the concentrations, or examples of that. Calculate initial rate for each experiment. See how the initial concentration affects the initial rates and figure out the order for each reactant. Once you know the orders, you can work out the rate equation. Measuring the initial reaction rate. For some reactions, sudden color change happens when a product reaches a certain concentration. Use iodine clock solution reaction, and the reaction we're monitoring is H2O2 aqueous plus 2I minus aqueous plus 2H plus aqueous to form 2H2O liquid plus I2 aqueous. What happens is a small amount of sodium thiosulfate solution and starch are added to the reaction mixture. Sodium thiosulfate solution reacts instantly with iodine being formed. Once all of the sodium thiosulfate solution has been used up, any more iodine formed stays in the solution. This turning the starch indicator blue-black. Varying the concentration of iodide / H2O2 hydrogen peroxide while keeping everything else the same or everything else constant will give us different times for the color change. The color change that happens when a product reaches a certain concentration, and therefore we can use this to work out the reaction order. For other reactions that produce a precipitate which clouds the solution, we measure the time taken measure the time taken for a mark underneath the reaction vessel to disappear from view. And for other reactions, you can work out the initial reaction rate by measuring the time taken for a small amount of product to be formed. Continuous monitoring. The idea that we're following a reaction to the end by recording the amount of product / reaction you have at regular time intervals. So follow a reaction to the end by recording the amount of product / reaction you have at regular time intervals. So in this case, changing pH. If the reaction produces / uses H plus ions, the pH of the solution will change. Makes sense. So we can measure the pH of the solution at regular intervals and therefore calculate the concentration of H plus. Gas volume. If a gas is given off, collect in the gas syringe and record the amount you have at regular time intervals. To find the concentration of reactant at each point, we have to use the ideal gas equation to find out the moles of gas we have, then use a mole ratio to work out the concentration of reactants. Loss of mass. If a gas is given off, the system will lose mass. Measure at regular time intervals with a balance, and then use mole calculations to work out the gas loss and therefore the moles of reactants left over. Color change. Now this one definitely is the longest one. So first thing we need to do is we track the color change using colorimeter. And basically this measures the absorbance, and the absorbance is the amount of light absorbed by the solution. More concentrated the color solution, higher the absorbance. More concentrated color solution, higher the absorbance. We want to plot a calibration curve, a graph of known concentrations of the colored solutions plotted against the absorbance. During the experiment, we take a small sample from reaction solution at regular intervals. And read the absorbance. Use a calibration curve to convert absorbance at each time point into a concentration. Plot calibration curve. During the experiment, take a small sample from reaction solution at regular time intervals. Read absorbance. Use calibration curve to convert absorbance at each time point into a concentration.